So my name is Dahlia Kirschbaum. I'm a SERVIR ASTPI, and I'd like to give a brief overview of our project that we've just started, focusing on developing a landslide hazard and a risk assessment system for the SERVIR Mekong region. So I'm the PI, but I also recognize my colleagues, Pukara Matya, Thomas Stanley, Robert Emberson from Goddard, as well as our colleagues at the ADPC and the SERVIR Mekong region that are collaborating and working together in this project. So just to give a bit of background of where we're coming from, our team has been doing global and regional landslide hazard modeling for quite a while. The implementation that we've developed is called the Global Landslide Hazard Assessment for Situational Awareness, and we're calling this LASA. And we're currently in version 1.1 because we've recently made some upgrades. And so what it consists of is a global susceptibility map as well as some near real-time precipitation information we're using from the Global Precipitation Measurement Mission multi-satellite product called iMerge. And so this is a framework. It's publicly available, written, scripted in Python on GitHub, and we have several different implementations of it. We have one running globally at NASA's Precipitation Processing System here at NASA Goddard, as well as we've been working with the city of Rio de Janeiro, who've implemented their own version of LASA called LASA Rio, which has been operational since fall of 2018. And then we're working with other groups in varying capacities to develop a framework that works for them in countries. And so the planned activities with the focus on this is updating. Currently, we're working to update LASA to a second version, and this is funded through the Disasters Program at NASA. And we're also working, obviously, as through this project to cater this type of modeling framework to the Mekong region, obviously working together with ADPC, the Mekong River Commission, and others. So again, just to go big picture, our global susceptibility map is developed using multiple factors, including slope, forest cover loss, the distance to road networks, distance to fault zones, and also soils information. And so that data is coupled with precipitation information from GPM. And so this shows you kind of what this type of information looks like. It has a 0.1 degree, 30-minute resolution, and it highlights precipitation from 65 degrees north to south. And then this is an example of the implementation over Hurricane Willa, which you can see made landfall in Mexico in 2018. You can see the storm with GPM rainfall coming over Mexico, and as it makes landfall, you see what we call a landslide nowcast, which is the combination of high susceptibility, either moderate to very high susceptibility, shown in yellow to red, and then that is overlaid with precipitation over the last 7 days. And so what we can do here is we can look at in near real time, such as we saw with Hurricane Willa, this pattern of near real time potential activity with a latency of 4 hours based on the retrievals from the GPM algorithm. But we can also look at this retrospectively to start to get a sense of when landslide season is around the world. And so this is about a 17-year average, what we're calling landslide climatology, which shows the average potential activity by month. And then what you're seeing now is overlaying this with different landslide information that we have reported through our global landslide catalog, which we have available for the past 10 years. All right, so moving on, why am I giving you all this background? Well, it really forms a foundation for how we're conceptualizing this project, in that we have a suite of different tools and resources that we've been developing, but the next step is to cater this and focus on how we can look at this over the lower Mekong region. And as you can see, this is our susceptibility map, and on reported landslides, you can see the distribution of where the highest susceptibility areas are in these countries. And so the goal of the project is really to enable and inform decision-making on landslide hazard, risk assessment, and do this leveraging Earth observation data. But also it's to build the capacity of regional and national agencies to really increase awareness and support preparedness activities. And in doing this, we'll be able to create a suite of products and services that we co-develop with the local users, be it ADPC, the MRC, and others. And this will help to characterize where and when landslides may be happening, model these processes, and ultimately forecast potential activity. So the way that we're doing this is we divide this project into 3 phases. The first is project planning, and so we really think of this as kind of the first 6 to 12 months. And so we're doing a needs assessment, or we will be working with stakeholders in the region and mapping, kind of stakeholder mapping of what their needs are, and as well as some of the products and services, what's going to be most helpful to these different groups. And the other thing we're doing right off the bat is we're working to improve our landslide inventory maps, because having better information on where and when landslides are happening are fundamental to improving modeling and monitoring going forward. The second phase of this work is to design and implement these landslide mapping, susceptibility, rainfall analyses, and ultimately to develop a Lhasa Mekong model that can be transitioned to the Mekong River Commission and others. And we're also going to go another dimension, which is to characterize exposure and ultimately, hopefully, get towards risk in this region, though it's difficult for reasons that I won't get into now. And then the last phase is really about, evaluation, transferring this system, and figuring out how we can move these services and capabilities to be run operationally at ADPC or with stakeholders in the region, as well as sharing information and performance metrics on how we're doing, and training as well. So we've done a bit of homework with respect to kind of where different countries are with respect to the susceptibility maps. They have landslide databases, early warning system, etc. And as you can see by the colors from like pretty advanced to not so advanced, there are some large discrepancies in kind of what the needs are across this region. And so we've already had initial conversations with ADPC and the team at the SERVIR Mekong Hub, and we've identified that we're really going to start our efforts focusing on the Mekong River Commission, because at present they have no operational system, and this is something that they are extremely interested in pursuing. So the way that we're again conceiving of this is a series of input, services, and products. And so you can see kind of the flow of how one is important to inform another. So we have optical imagery that we've been pulling or we're working on, either commercial or publicly available sources. We have automatic landslide mapping through some semi-automatic detection mechanisms and algorithms that Dr. Pukaramatia has been leading for our team, and those will all be in the public domain, both the inventories and the model, by the time this project is finished or as it's developing. And so we'll develop landslide catalogs that then will inform the susceptibility and hazard modeling. And again, you can see the different inputs in the second column of the landslide information, as well as Earth observation data such as DEMs, digital elevation models, land cover, etc. And then we also have socioeconomic data. And so we were going to be looking to the hubs to identify any regional information, be it geology or soils information, soil moisture, as well as socioeconomic data that may help to better inform both our hazard as well as exposure and risk modeling. And so just to kind of provide a big overview, and I'm happy to share this with you, these are the different services, products, questions, outcomes, and impacts that we could envision with the system, but we recognize that we can't do everything. And so really the goal of this first phase is how we can work with ADPC and others to consider the different elements of this suite of tools and services. So as I said, we're actively starting already automatic landslide detection. We're also doing multi-scale landslide mapping, modeling based on, catering to the needs of the Mekong region. And then ultimately building this system which could have many different flavors, everything from near real-time products to forecasts to looking backwards to identify this kind of seasonality, and even in projections into the future. I mean, I think that there's a lot of options. As I stress, we can't do everything, but I think that this could be a roadmap for many different ways that this project could evolve. And I want to emphasize that, in talking to some of the other projects, it seems like there's already overlap in terms of many of the data that we could share or activities we can do together. So just to close, here's my contact information as well as that of my co-Is that will be participating in this project actively. And I look forward to participating with the rest of the team. So thank you very much.